Hi, everybody. Today we're going to talk about logic, specifically about conditional statements. So here we have a conditional statement. If x is less than 10, then x is less than 15. A conditional statement is a statement written in the form if, then. Here we see the word if, something happens, the word then, something happens because of it. So we have a conditional statement. When we have a conditional statement, we have two parts to the statement. We have the premise, which is everything after the word if, but before the word then. And we have the conclusion, which is everything after the word then. What we need to do here is we need to write the converse, inverse, and contrapositive of the following conditional, both in words and symbolically. So here's our original conditional statement in words. Symbolically, we write any conditional statement as key, arrow, Q. And what that says is if P, then Q. If the premise happens, then the conclusion follows. Let's get writing the converse, inverse, and contrapositive. Here we have the converse of the original conditional. The premise is now x is less than 15. And the conclusion is now x is less than 10. So if x is less than 15, then x is less than 10. Remember, the converse of a conditional statement is when you switch the order of the hypothesis and the conclusion, of the premise and the conclusion. The premise in the conditional is now the conclusion in its converse. The conclusion in the conditional is now the premise in its converse. Here we have the inverse of the original conditional statement. That would be if x is greater than or equal to 10, then x is greater than or equal to 15. So notice that the order didn't change, like in the converse. The premise and the conclusion are still in the same spots as the original conditional, but what did happen is both the premise and conclusion were negated. The premise is the opposite of what it was in the original. In the original, we had a less than sign. Now in the inverse, we have a greater than or equal to sign. It was flipped. In the original, conditional, the conclusion was a less than sign as well, and now it's also a greater than or equal to sign in the inverse. And finally, we have the contrapositive of the original conditional. Notice that this time, both the original premise and conclusion have switched spots. The order has changed, and they've also been negated. So contrapositive is basically a combination of the converse and the inverse. You switch the order of the premise and conclusion, and you also negate both parts. We are talking about the 15 first instead of last, and we have the greater than or equal to sign that's negated from the original less than sign. The conclusion is talking about the 10 that switched order from the original. And the sign changed because we are negating it. So instead of having the original less than sign, we have a greater than or equal to sign. We still need to represent all of these symbolically. So for the converse, since only the order of the premise and conclusion changed, instead of writing if P then Q, we can write if Q then P. For the inverse, the premise and conclusion don't switch spots from the original. Each part just gets negated. So we can symbolically represent that as not P, then not Q. That little squiggly symbol that I wrote down means negation. It means not. If not P, then not Q. It means we negate the premise and conclusion. And finally, for the contrapositive, since it involves both switching the order of the premise and conclusion and negating both, we can symbolically represent it as if not Q, then not P. Conditionals can be used to draw logical conclusions. A conclusion is said to be valid if the premises support the conclusion. So basically, we can say that a conclusion is valid is assuming that all of the premises are true if the conclusion can be logically deduced from the premises. Are these valid conclusions? If it has wheels, then it is a car. If it has wings, it is a plane. Therefore, a car is a plane. Take a second. Given the two premises, the two conditional statements, is the conclusion drawn valid? If you said no, congratulations, you're 100% correct. This conclusion does not follow logically, assuming that the premises are true. Let's take a look at B. If you are at least 17 years old, then you can have a driver's license. Mike has a driver's license. Therefore, Mike is 17 years old or over. Take a second, pause the video, think about assuming the premises are true, assuming that Mike has a driver's license, and assuming that if you are at least 17 years old, you can have a driver's license. Does the conclusion about Mike logically follow? If you answered yes, congratulations, you are correct. Wonderful. Let's take a look at another example. If I am a man, then I am mortal. Dave is a man. What valid conclusion can you make from the above statement? So pause the video, take a second, think about, based on these two premises, assuming that they are true, what valid conclusion can you draw? If you answered that Dave is mortal, you are correct. Congratulations. There's probably a bunch of other things you might be thinking about Dave or about men being mortal, but based on these premises and only these premises alone, we can conclude that Dave is mortal since Dave is a man. What is the converse of the first statement? Take a second and write down the converse of the conditional, if I am a man, then I am mortal. If you wrote down, if I am mortal, then I am a man, wonderful. That would be the correct converse of the conditional statement. Switch the order of the premises and the conclusion. Find the truth value of this statement. Take a second. Would you label this statement true or false? If you answered false, congratulations, you are correct. Although it might be true in the original conditional that if you are a man, then you're mortal, because we do know that if you are a man, if you're a human being, then you are mortal. We don't have any immortal human beings that I know of. But the converse here says, if you are mortal, then you have to be a man. But that's not true, because you can be mortal and you don't have to be a man. You can be a human being that identifies as a different gender. You can be an animal, right? Animals are mortal. You can be lots of other things. Sometimes, in some certain specific situations, you can have a conditional statement that actually has a true converse. When this happens, we can symbolically represent a true conditional, and its true converse in the following way. If P then Q, that would be the original conditional being true. I'll write here T for true. And if Q then P, which means that the converse of the original conditional is also true. Or, to simplify this and write this in a more coherent way, P if and only Q. This double arrow over here is read as if and only if, or for short, IFF. That is an abbreviation that you can use. Everybody in math will know what you are talking about. And if you take a look at the double arrow, it is a combination of the arrow that's starting at the left and going towards the right, and the arrow here that's starting at the Q and going towards the P. It's like you're taking both of those arrows and you're combining them into one double arrow. So we call this a biconditional statement when we have a conditional whose converse is also true, and we can combine them into one if and only if statement. So a biconditional is formed from a conditional and its converse. Once again, the converse has to be true as well. We read the double arrow as if and only if. We talked about that already, because the biconditional is true only if both the conditional and its converse are both true statements. Here's an example of a biconditional in geometry. A rectangle is a square if and only if all sides are congruent or equal in measure. So this is a biconditional definition of a square, because if you read it forwards or first or backwards first, you'll have true statements. Both the original conditional and its converse are true. For example, if a rectangle is a square, then the sides are congruent or equal in measurement. That's what it means to be a square, right? A square has equal sides. But if you read it the other way, starting back to front, if all the sides are congruent, then the rectangle is a square. That's also true. That's what differentiates a square from just being a regular rectangle. If you already know that all the sides are congruent, that makes your rectangle a square. So forwards or backwards, this statement is true. Both conditional and its converse are true, which makes this a true biconditional statement, using the words if and only if. Take a second and write down the definition of an equilateral triangle in biconditional form using the words if and only if. So I wrote down my definition of an equilateral triangle in biconditional form. A triangle is equilateral if and only if it has three equal sides and angles. If we read it forwards as a conditional, if a triangle is equilateral, then it has three equal sides and angles. Makes sense? That's true. If we read it backwards instead, if the triangle has three equal sides and angles, then it is equilateral. That also makes sense. That is what it means for a triangle to be equilateral. You can pause the video here and you can try out number 1, A, B, and C, and I will share the answers with you. Remember to pause because the answers are going to display in a second. Here I have the answers to 1, A, B, and C. Remember that the double arrows are present here, so you're writing a biconditional statement for each one, and that's why I'm using the words if and only if instead of if then. If it was just a single arrow going in one direction, then we would use the words if then to write our statements. Try number 2 out, parts A, B, C, and D. What you're doing is determining based on the premises given for each one, is the conclusion drawn valid? Remember to pause because the answers are going to display. All of these are valid except for C. Just because Owen does not live there near the ocean doesn't mean he has to live in Nebraska. He might live there, but he also might live somewhere else that's not near the ocean. Finally, here's one more to wrap it up. So take a look and see if you can determine the answer. Remember to pause once again. The correct answer is 1. These statements are inverses of each other. Notice that the order of the premises and the conclusion didn't change. In the first conditional, the 16 plus 9 part is first, as it is in the second one, and the 5 equals 4 part is in the conclusion, just as it is in the second one. So the order didn't change. All that changed was that the premise was negated from the conditional to the second statement here. And this premise was also negated. This conclusion was also negated to the second statement here. Notice it says not equals in the first one, and then it changes to equals. Thank you all for watching. Have a good rest of your day.